In this lesson, we will examine the regulations governing the use of supplemental oxygen and the flight crew supplemental oxygen systems that are required by the regulations. Supplemental oxygen is oxygen which is used to allow the crew and passengers to breathe normally at altitudes where they would not otherwise be able to do so without the onset of hypoxia. For flight and cabin crews of pressurized aeroplanes, supplemental oxygen must be available for any time longer than 30 minutes that the cabin is between 10,000 and 13,000 feet, and for the entire time that the cabin is above 13,000 feet pressure altitude. The minimum amount of flight deck supplemental oxygen to be carried must be sufficient for at least 30 minutes use for aeroplanes certified to fly at altitudes not exceeding 25,000 feet, and for 2 hours for aeroplanes certified to fly above 25,000 feet. There must be sufficient supplemental oxygen carried on a pressurized aeroplane to supply all of the passengers on board with oxygen when the cabin is above 15,000 feet pressure altitude, with a minimum of 10 minutes supply available. There must also be sufficient oxygen available for 30% of the passengers when the cabin is above 14,000 feet and for 10% above 10,000 feet. For unpressurized aeroplanes, oxygen must be available for the flight crew at all times above 10,000 feet. For the cabin crew, oxygen must be available at all times above 13,000 feet, and at all times longer than 30 minutes above 10,000 feet. There must be sufficient supplemental oxygen available for all passengers on board when the aeroplane is above 13,000 feet, and for 10% of the passengers above 10,000 feet. Flight deck crew supplemental oxygen is stored in high-pressure gas cylinders. Oxygen is stored in the cylinders at a pressure of 1,800 pounds per square inch, with the pressure being reduced by a pressure regulator or pressure-reducing valve to a suitable level for use. Oxygen pressure indication is provided for the crew by a gauge on the flight deck. In the event of the pressure inside the cylinder becoming excessive, the cylinder is vented to atmosphere through a safety disc. Indication of this fact is given by a discharge indicator located on the outer skin of the aircraft. In the event of a discharge, the green disc will be ejected, leaving a red painted area visible. The cylinders are fitted with shut-off valves to enable them to be removed from the aircraft for maintenance purposes. There is a charging valve to allow the cylinders to be replenished in situ. On some systems, there is a system shut-off valve on the flight deck to allow the crew to shut off the supply if required in an emergency. Flight crew systems are generally of the diluter demand type, although on some smaller aircraft, the flight deck may have a continuous flow type of system. In the diluter demand type of system, the flow of oxygen to the flight crew masks is controlled by a diluter demand regulator. On some aircraft, the regulator is a separate component. On others, it is an integral part of the mask. The diagram on the screen is of a panel-mounted regulator. However, the operating principle is the same for an integral regulator. The diluter demand regulator supplies oxygen on demand. Depending on pilot selection, this can be oxygen diluted with cabin air, 100% oxygen, or 100% oxygen flowing continuously under a slight positive pressure. There are 3 pilot-controlled levers on the face of the regulator. There is a supply lever with on and off positions, an oxygen selection lever with normal and 100% positions, and an emergency lever with 3 positions marked normal, emergency, and test mask. In the emergency position, 100% oxygen under pressure will be supplied. The oxygen enters the regulator through the inlet. The first component it meets is the shut-off valve. This valve is controlled by the supply lever. With the lever to off, the valve is closed. The on position opens the shut-off valve and allows oxygen to flow into the regulator. The oxygen will now flow through the flow indicator to the demand valve. The flow indicator is a simple mechanical device, which will be blank when there is no flow and will be white or yellow when oxygen is flowing. The position of the demand valve is controlled by the demand diaphragm. The demand diaphragm is sensing cabin pressure on one face and oxygen mask suction on the other. If the mask is not being worn or the wearer is not inhaling, then the 2 pressures will be equal and the demand valve will be closed, blocking off the flow of oxygen. When the pilot breathes in through the mask, there will be a pressure reduction felt on the right side of the diaphragm, and the demand valve will open, allowing oxygen to flow through it to the air metering valve. The position of the air metering valve is controlled by the aneroid or evacuated capsule. The capsule is surrounded by cabin air. With the cabin at sea level, the capsule will be compressed, and the air metering valve will be fully to the right. In this position, a large amount of cabin air will enter the regulator through the air inlet non-return valve and mix with a small amount of oxygen before being fed to the mask. As the cabin altitude increases, the cabin pressure will fall. The capsule will therefore expand, moving the air metering valve to the left, allowing the ratio of oxygen to air to increase until, at a cabin altitude of 32,000 feet, the cabin air will be shut off and 100% oxygen will be supplied. If the cabin air is contaminated, possibly by smoke, to prevent the pilot breathing contaminated air, 100% oxygen can be selected using the oxygen selection lever. Moving the lever to the 100% position closes off the cabin air inlet and opens the supplementary oxygen valve. Bypassing the air metering valve, allowing the pilot to breathe pure oxygen. In the event of thick smoke, high cabin altitude or stress, pilots can select 100% oxygen with a positive pressure using the emergency lever. When emergency is selected, the demand diaphragm is pushed to the right, unseating the demand valve, allowing a constant flow of oxygen at a pressure higher than the cabin pressure to enter the mask. This gives a positive pressure within the face mask, which ensures that smoke is kept out and increases the oxygen saturation of the pilot's blood. The emergency lever also has a spring-loaded test mask position. This position opens the demand valve and allows oxygen at a high pressure to flow to the mask. The relief valve will bleed off oxygen should the pressure in the regulator become excessive, possibly due to failure of the pressure regulator. It is a regulatory requirement that quick donning masks be provided for the flight deck crew on all aircraft that have a maximum operating altitude above 25,000 feet. The mask must be capable of being fitted with one hand in a maximum time of 5 seconds. The pilot must be able to carry out all normal communication tasks with the mask fitted. A typical example of a quick donning mask is shown here. It is a combined mask and regulator. The regulator has all the features of the panel-mounted regulator. When not required for use, the mask is stowed in a panel-mounted box, in such a way that the regulator controls and the feed hose protrude through apertures in the stowage doors. When the mask regulator is stowed and the box doors closed, oxygen flow to the mask is prevented by a shut-off valve inside the box, this valve being held closed by the reset test lever on the left door. The flow indicator is visible with the doors open or closed. The mask is held to the face by a harness constructed of elastic tubes. The tubes are inflated by oxygen to allow rapid donning of the mask. The harness is deflated when stowed. It will fit all head sizes. The control for normal or 100% oxygen flow is a lever on the front of the mask, marked N, and 100% push. The N position is equivalent to the normal position on the panel-mounted regulator and will give an oxygen-air mixture on demand. By pushing the lever to the 100% push position, the wearer will receive 100% oxygen on demand. Rotating the emergency control knob to the emergency position changes the flow from diluted demand to a positive flow, in the same manner as the emergency lever on the panel regulator. The emergency knob is also marked Press to Test. This allows the mask to be tested while stowed. When pressed together with the reset test lever, it allows oxygen to flow into the mask. Flow is checked on the flow indicator. The mask is withdrawn by grasping the red release grips between thumb and forefinger. This action causes oxygen to inflate the harness, allowing the mask to be rapidly fitted to the face. Subsequent release of the grips deflates the harness, which will now form-fit the head. The masks have microphones connected to the aircraft's communication systems. Some have integral smoke goggles, as shown here. On others, there is a mask ventilation feature, which, when selected, will provide ventilation to the separate smoke goggles, which sit over the nose section of the mask in order to overcome misting problems. The vent valve selector is slid down to open the vent valve and allow oxygen into the goggles. That is the end of the lesson on flight crew supplemental oxygen. A summary of the regulatory requirements is shown on the screen. The full regulations can be downloaded from the JAA website. Remember that the regulations about the amount of passenger oxygen to be carried appertain to the actual number of passengers on board. The regulations need to be memorized. Click to continue with the lesson summary when you are ready. Here is a summary of the other main points of the lesson. Flight deck crew supplemental oxygen is stored in high-pressure gas cylinders. Flight crew masks for aeroplanes operating above 25,000 feet must be of the quick donning type. The mask must be capable of being fitted with one hand in a maximum time of 5 seconds. The pilot must be able to carry out normal communication tasks with the mask fitted. Each flight crew member has a diluter demand type of oxygen regulator. The graphic on the screen summarizes the operation of the diluter demand regulator.